Hi, I'll be explaining how nomenclature works. I'll give a little intro. So basically, nomenclature is the process of naming compounds with different names so that they can be identified as individual chemicals. The first compound we have is called the ionic compound, which is composed of one metal, which is positive, also known as a cation, and one non-metal, which is negative, which is known as an anion. The other compound that we know of is covalent compounds, also referred to as molecular, and this is composed of two non-metals, which are negative, and again, anion. To do nomenclature, you'll need a periodic table. Now, everything over here is non-metal, and do you see this staircase? Everything thereafter is metal. And these are your charges at the top. We'll start by naming ionic compounds. So we'll start with looking at our chart. We'll find sodium is on the metal side, and chlorine or chloride is on the non-metal side. So we know that it's ionic. So basically, we're going to take their charges of +1 and -1, and we're going to write them like that. Next, we are going to basically cross them as if they're coming down to switch charges. We're going to balance the equation, and because we pull down the charges, it's basically going to be just NaCl, because if you have charges of just one, they cancel. But let's say this was 2 and this was still 1, and it were to cross. Instead, when the 2 would come down and the 1 would come down, it would now be 2 and Na1. Now we're going to move on to ionic compounds with a transition metal. Now three things that we should prioritize here is name of transition metal, Roman numeral, and always in parentheses, non-metal ending with "ide." Now with the Roman numeral, one thing that helps is if so it goes up like this. This is 1, this is 2, this is 3. Then when you get to, that's 3, and then let's say you go to 5, right? So this is 5. Now anything to the right of it will add 1, and anything to the left of it will subtract 1. So if this is 5, if you put a line to the left of it, it will become 4. But if you put a line to the right of it, it will become 6. You continually add, it will become 7, 8, so on and so forth. For this example, we have iron as our transition metal. Then this will be our charge. So with our charges, it actually tells you what the charge of iron is, or whatever your transition metal is. So whatever number's here, that's what it will tell you. And this is our non-metal. So basically, we know that this is the charge of iron, and as we saw before, chlorine has a charge of -1. Now, so we have, it's all lined, this is their charges, so now we need to balance it. And when we do the crossover, when we take 2 and cross it, and 1 and cross it, we achieve FeCl2. That's our balanced equation. In addition, some transition metal charges have specific Latin names. The ion of transition metal which has the lower charge, acquires the Latin name ending in us, so in the lower, as opposed to the higher charge, which ends in ic. Now, if you notice, the charge here is 2, and there's only a charge of 1 here. So, if we pull down here and we notice that this is the higher charge, so it's going to end in ic, cupric oxide. This stays the same, but only the transition metal changes. So it's going to be cuprous because it's 1 less than this compound here, but it's going to stay the same for oxide. Next we'll do polyatomic atoms, and basically that just means that there is 2 or more elements within an atom. Now in a couple seconds I'll drop in all the polyatomics atoms you should know, and you should memorize these. Now we're doing ionic compounds with polyatomic atoms. You'll need to state the name of the metal, the polyatomic atom, and instead of ending in ic or us, something along those lines, it will be ending in 8 or 8. So looking at this is when our polyatomics will come into play. So here we have calcium phosphate. Now this isn't phosphorus, it's a polyatomic, and this one falls under, so calcium, we remember that, so it's a 2+ charge. Now I need to remember the phosphate charge, which will be PO3 -4. So now that we have here, we need to be able to cross the charges just like we did in the other scenarios, where, one second, where we're going to take this one and this one, but leave this one and put parentheses around it. So basically we'll be crossing the 2 top charges and leaving the 4. And it will end up looking like this. So we'll get Ca3 bracket PO4 bracket 2. Now we're focusing on ionic compounds with a transition metal and polyatomic atom. So what we need to focus on here is stating the name of transition metal, adding the Roman numeral, and the polyatomic atom. For example, we're doing copper to nitrate. So this is the polyatomic, and copper, we know from here the charge is 2. So we know that the polyatomic for nitrate is NO3 -1, and for copper we know that the charge is +2. So now we need to balance them. Just like before, we're going to take this one and bring it down, but because this is part of a polyatomic, we want to keep the parentheses around there and only bring down the charge. So we end up with our final answer, covalent compounds. So what you'll need to remember is the prefixes, and I'll insert a picture of 1 to 10 that you need to memorize. You don't need to cancel or cross any charges. So for our first example, we have diphosphorus pentaoxide. Now it's always going to be in the steps or order of prefix non-metal, then prefix non-metal. So basically we have 2 phosphorus, 5 oxygen, because it's going to end in IDE for the second non-metal. So basically we're gonna get P2O5, and that, because we do not cross or cancel anything, we just keep it with the same non-metal. We have N3O6. So what we need to decipher is what is 3 in prefixes and what is 6. So 3 is tri and 6 is hexa. So because we don't cancel any charges or anything, we're literally going to write trinitrogen hexaoxide. But always remember to finish the second non-metal with "ide." And that's it. That's your compound. Next, we'll be talking about acids. 2 things you want to prioritize or understand is that the prefix hydro is placed in front of the non-metal, and modifying the end to "ic" after. Acids have different names, but one way to identify acids is to see if there is an H before the molecular formula of a compound. For naming acids, the prefix hydro is placed in front of the non-metal, and the end is modified to "ic," and they kept the fluor for the fluoride and added the acid because it's aqueous. Here, if it was just HFG as in gas, you would just keep it as hydrogen fluoride because it's referring to a gas, not an aqueous substance. Now we're moving on to salts containing polyatomic ions. One thing to remember is that polyatomic ions are ions which consist of one or more. An example of this is potassium nitrate. Now, one ion is potassium and the other is nitrate, but nitrate is made up of more than one atom, so that's how you know it's a polyatomic. With the oxidation states, they have the same one, so you know when you cross them, you're just going to end up with KN3.